Did you have a good night's sleep? Ready to rock again? So, today we are studying a bit about advanced biological treatment process and importance, right? So, yesterday we saw very fundamentals of biological processes, and we also had a good site visit. What you studied here, you can able to visualize, right? Okay. So that we did. You saw the biological treatments still more popular in the today's situation, right? We use activated sludge process, we use attached, and various other biological processes. Biological processes are more popular because they are easy to operate. But what you need, it needs a continuous monitoring, right? But the greatest advantage is you are not converting the pollutant one form to another form of pollutant. It is degraded. Why we don't use chemical processes? We don't want to convert one form of pollutant to another form. And sludge is produced, it has a chemical where you want to do it. But there are certain situations, if it is not biodegradable, what is it? We go for chemical processes. In the chemical process, what we are going to do is, we are converting the pollutant or toxicity, we are reducing the toxicity. We are making it less harmful in the chemical. Sometimes it may be possible we may be converting that into which has a not much impact on the environment, on the water quality. That is we do. So, how did you find the yesterday's site visit? See what you learned here. You can see some things are working on it. Okay? That is why the needs a continuous improvement, monitoring. How you will do monitoring? You will find out, do deep analysis, sampling, you analyze whether things are working. You want to see not just the influent and the effluent, right? You want to make sure that each unit is performing well. And I was giving you an example. If there are industry, if they are big, they can have their own treatment. If they are small, medium, there is also provision. Right? There are different methods to deal with the problem if you want to deal, if you want to find a solution. That is how one of the example yesterday. We saw two examples. There are small industries where they cannot afford treatment plant of their own. That is why what they did is, group of industry come together and they wanted to have a common effluent treatment plant. What they did is, they can discharge the wastewater at some point, equalization tank, they mix wherever. If it is some industry may be discharging a pH of low value, some may be high, so neutralization takes place. That is how you will save some money also. Otherwise, what you are avoiding the two treatments. You can't, you have to discharge the wastewater in a certain pH in order to protect the environment and water quality, right? So if you are doing some combination, and that is what you saw there in the common effluent. Here it is the individual, because that's a big industry. They can afford, that's why they constructed a big treatment plant and there. But discharge, of the treated effluent. Where you are discharging is important. If you are discharging to a river, river should be flowing. You just cannot discharge it where there is no flow. That is the meaning. Discharging it to river means what? River means it is flowing in the word, right? But that is how the definition of river is. We are not knowing if it is not flowing is a river. But these are the also situations. You cannot discharge where there is stagnant water is there. Where it is flowing seasonally. That means what happened? Little water somewhere there in the pond, if you are discharging, what happens? That will also spoil. So that is why earlier people who have done, they were not knowing that river means it is flowing. Not flowing, you cannot. And also when you are discharging, I wanted to tell about the mixing zone. If you think that there is a discharge to the river which is flowing, correct? How much you discharge, where you discharge is also important. Pollutant, if you cannot make it 100% the water, which is same as a river. But I also mentioned river has a capability of treating itself to some extent. You want to take advantage of that. Don't take the disadvantage. If it is capable of handling about 100 milligram of BOD, if you discharge about 1500, how it will happen? Anaerobic condition will be created. If it is not flowing, if you are putting more there, it is maybe bacterial load is high, right? Maybe pollutants are high. So these are the causes. So we do, when you are discharging to a river, river means flowing. I have to add that definition today. So when you are discharging, we study about the mixing zone. What happened? This BOD is 100. The BOD is 0 there. If maybe 1, 10, 5, 4. Then you will see how much is the impact. There should be a proper mix where you are discharging. If it is stagnant, if you are discharging there, that portion will become an anaerobic condition. And another thing, what you will see? You will see the oxygen concentration. How much is the oxygen concentration in the effluent and also oxygen concentration in the river. The river, it must be good. But whether that is happening, that you will have to see, right? Then you will find out what is the right position. It is not that we have a discharge point here, whether water is there or not, the river is flowing that side, you will discharge. So those are the conditions also you should keep in mind. Okay? That is very important. So what is your ultimate goal? Is to make it safe, to protect water quality and environment, create a safe environment. Is it? So you should also consider all these factors when you are doing it. If the river is flowing that side, then your discharge point should not be here. You cannot just discharge on the ground. It has to be discharged in the flowing water. That is the meaning of discharging it in the river. And there are small creeks also. If we have a small creek, then you have to be more careful. If you cannot just, if you are discharging it to the creek, there is always a certain species which are sensitive to the temperature, sensitive to the pollutants. That you have to make sure. If the temperature is high, you cannot get discharge on the river. What you will do? There are many solutions. We talked about that. Solutions, you reduce the temperature at your site. That is what you are doing. You are giving a pre-treatment, making it safe, then you are discharged. So that is why these are the conditions should be decided looking at the situation side. You cannot just give an authorization, you just discharge and in the monsoon it is flowing, it is flood, a big flood is there, it will take place. Which is not. You will have to see, do the seasonal studies. When you are discharging to the rivers, you have to be extra careful, right? But these industries which are discharging it to another wastewater treatment plant, that is what pure to W is the another word there, right? So if you are discharging, what happens? You will pre-treat and discharge to another treatment plant. You have a little protection there that they will take care of. Then what is the responsibility of the city's wastewater treatment plant? They have to make sure that they are not getting anything which will cause an interference or pass through. So then they will be more careful because they also need authorization. These people also need an authorization. So that is why this is go hand in hand. So those things are important. The location where you are discharged, right? If you say, "Oh, initially we thought we gave our authorization in the river, so they are discharging. In the summer there is no water. What you will do?" It is not like that. That is why when you are giving authorization, you will study the flow of the river. You just cannot say discharge it. That is why there is an equal responsibility on this side also. Once you are this side of the unit, you should have a thorough understanding what you are doing first. Otherwise, what happen when you give any authorization, you always think the period, you put a conditions under what circumstances you will do that. Otherwise, big industries will take an, I don't say advantage, but they will say legally we are allowed to. Yes. Means what? This means when you are receiving an authorization, you do not have that condition. Big industries, may go to the, they may opt for a legal solutions. So what you will do? How you will cancel? If you give an authorization, you may be giving it for 5 years. That's the usual side. And you are not aware of the seasonal variation of the river. Then people who work with the river, there may be a big department, no? Who works on the rivers here? Are there any departments or any people or government people work on the rivers? Hydrological department. See, you have a lot of data about the river flow. When it is flowing, when it is not flowing, then you say that these months or 20 years data it was flowing. That's why we issued the authorization. But this year is not the situation. Then you should have an clause. In this situation, they have to cancel the permit. They have to cancel the authorities. They will have to do something different. And yesterday, I observed two things. I'm happy that you guys are were asking the questions. So I think you are good too. That's good. But also, you heard about COD, right? What do you mean by COD, right? It's not degradable. That's why there is a ratio. Should always make sure that certain things are not biodegradable. That's one. Then, if it is a paper industry, what is another issue always is the color. They said in the color industry, in the paper industry, we use a decolorization. It is hard to remove color from the system, right? It is difficult to remove the color. So What you will do? You will have to put the limitation for the color. That is what somebody was asking yesterday or day before yesterday, what the local people will do. See, in the general, the state standards, you may not be having the color for all the industries. For other industry, if it is a food industry, you need not to put the limitation for the color. But if you are issuing an authorization to the paper industry, you know, in this area, this is a local area. So you should have a local limit for that. In this area, in this, you should have the limitation for color. City, which is this city, will say that these are the limitation. If you are discharging it to the sewer line, if you are discharging, you should have this temperature, this color. When there is a paper industry, there may be a lot of small scale industries also. The big industry may be having the big treatment plant. They are afforded. But small industry which are there related to the color, if they are producing any color, discharging it to the sewer line, that also you should think. So this is how I am telling you, there are different layers of regulations. Local is much stronger than other. You can take that as a guidance, but the local limitations differ from region to region, type of industry to industry. There, that's why the local limitation comes into picture. So we have seen the data requirements for an activated sludge. We will go little the number wise. The number wise, we will study in the advanced treatment, biological treatment, what should be the range. If I say good, bad, better, best, it has no value. If I say number, then you should start thinking, right? So that is why the numbers are important. How you analyze this, is it? It is the language of the wastewater treatment that you should be able. That is used for different purposes, right? So that is why I have put few slides which are used yesterday in between as far the data is concerned. Why? Because you should be able to see what is the purpose of that data. If I give that data to you, you will say what is the range, what is the research, why it is coming this value. Researcher people will think in that different. If I give that data to the regulators, hey, this is beyond our limit. See, purpose is different. If I give any management student here, if I give the data to, I missed your name. If I give that data to Vidya, how much you will spend to remove this much? How much I can tax the people or the industry? Purpose is different. That is why you see some of the slides here, because the purpose is different. Please, just I tell. So different group of people, how it is analyzed. So that is important. That is why group of people will work. If I give that data to someone in an NGO or people who are proactive, they will think in a different direction. Why it is high? Why? What is it causing to the environment? What are the health effects? Right? Their purpose is different. And if I give it to a marine biologist or people who work with the fisheries industry, they will think in a different way. If you discharge it to river, what about the fish? Right? So that is why the purpose is different. You should see all. That is why there is a big collaboration. We may have to sometimes cross side by side with the different departments to involve. Is it? And that is important. If it is a human health department, oh, this is causing this. Order is there, what action you are taking. If it is a public, They don't know how much you are discharging, what you are discharging, where. It gives a bad smell. That is their concern. Is it wrong? No, it's not wrong. They want to see what you are going to do. Okay? That is why what they can do, industry can, they are also smart. They will discharge when you guys are in deep sleep, in the late night, in the middle of the night. So you will be happy. You don't know. Morning everything is fresh. So this is how you interpret, how you do. That is all important. When you are giving authorization, it is not just like that. You should be smart enough to understand what are the consequences, where it is going to affect, how it is going to affect. If you say that you have done something that way, no. That is why your authorization may be cancelled at any time. That is possible. You will also put, there are also legal advisors on your side also. You should, that is why when you do, it goes there. They will see if their data is different. If you send it, they will see how legally I can defend. Right? So that is why these data are very important. Because if it goes to a court, how we will define your document and the date. I may not be having some person who is deciding. He may not be having a background what you are thinking in what with a lot of thoughts what you have written. He will say that how many readings you have taken, when you have taken. You don't know. If you don't have that proper understanding, documentation is very important. That is why when you are writing anything in a legally, you should always understand what are the consequences. Right? You think that it may go there, judicial. There are situations. They will also appoint a lawyer. There are situations with me also sometimes. No, I will not accept this. So what you will do? So that is why it is a thorough understanding. Technically, you should be served. If you want to do the things right, you can just, you are not on a willpower. You will do just theoretically you cannot do this. You should have a sound knowledge and understanding. That's why you have to keep updated, think in all directions, because it is a responsibility. For that, you will have to do a lot of effort. It is not necessary that everything should be known by one person only. You can ask an expert. So here is the expert. So I will send that document, see, I will get a feedback. What you want to do. Hey, no, they will see their point of view. Is it? Different eyes. Just different eyes. Right? That is possible. That's why enormous data. What you have understood, what I brief, before starting, I always brief what is you have learned. I think it should be useful. At least your thinking process will start how you think, right? We did how this framework is developed. Then we saw what are the different components. It is not just you know, you have to take one example and your water quality is fine. Right? Your all environmental safety is achieved. So that is why you developed a framework. You went on finding what are the different components, how they will impact. What are the different groups of people? I just mentioned. If you are doing how many people like this, you need experts. It's kind of a management side. You have to see all the scientific concepts. Scientific has a need and a support. You can't say that why this number. I interacted with some of the people today, right? It was interesting. I give my feedback also. They were doing some research. When you do research, you see why, how, when. You should. Nobody need to tell you. You should ask yourself this question. So that is why it is important. When you are what I suggest is when you are in this, put your mind completely. Then when you go, you enjoy. That's why I always used to tell my students, when you are in the classroom, full attention. When you go outside, full. This will not be, you will not get this when you go outside. Right? So that is why making use of the time. Learning has no limitation. You can learn anything. Nothing is, undermined. Any information is not, it will be helpful. That is my understanding in my 33 decades of experience. Different place, different organization. Everything is useful. It will give you a mind to think how you should think rightly and make it, determination, good decisions. That is all. What choice you want to make. Right? There is no shortcut. Shortcut can always produce a shock. Right? That is how. That is what I wanted to tell you, that the data, when it is there, you should think in a different direction. If you don't know, you can ask someone who is a knowledgeable. You cannot say I know everything. That is no, it's not that. Because your working outcome is important. Your personal is not important, right? The things which will remain in the system, you are building a system which has to run for many, many years, right? That was the intent. So yesterday we saw the treatment plant, we have seen the aeration, what is the very fundamental thing. We'll just screen quickly and add little bit. So this is the aeration pond. Similar to that, you saw there, aerators are put. What are the different kind of aerators, how they are installed, and what is the chemical reactions. We will see dig little bit. What is data? What you want to do? Why? What are the basic data you want? Is it you want BOD means BOD5? Why BOD5? What is that for? 5 days. Why only 5 days? Huh? Ah. So BOD5 is the 5 days. How much is the degradation you want to do? Right? How much is if you say BOD means what? If I say BOD is 100 milligram per liter, what it indicates? That you have seen estimate, right? There were standard glossary. I also explained it. That you measure in terms of the oxygen consumption. Oxygen consumption. When you design a aerator, what you will do? You will have to take nearly 5 times more than that. How much is the oxygen concentration in the air? 90? 20. It is less than that, little bit. Around you can say 20, less than 9. It is between 19 to 20. That is the fact. So we take 5%. When you design a aerator, you make it 5 times because that is the air. That's why it needs a lot of power. When you put a aerators and it provides the air which has about 19 to 20% of oxygen. Correct? That's why your aerator should be able to provide 5 times the air. So that is the design aspect. Just I'm giving you a hint. Right? So that the total suspended solids, pH you know already, and chlorine residual, ammonia, oil and grease, and fecal coliform. What is the E. coli? We always talk about E. coli. Means what? If the concentration in the water is high, if you find the presence, you say that it is contaminated. Right? Why? The presence of E. coli bacteria shows that in water there is a mixture of sewage. So that's why we say that is the indication. This water is not. That's why when you are discharging it to the river, we want to make sure whether are there any contamination. Right? Your discharge point to the river should be such that in the flowing water And downstream, there should not be any intake water for the drinking purpose. There is a town. They have an intake structure there. They take the water from the river, treat and supply it to the people. That is why you cannot discharge to the upstream. How you will calculate? You can calculate there. That is how I said what is the BOD, what is the oxygen in the river, oxygen in the industry, which is discharging, and then you will find in a number combined value BOD and oxygen. By the time it reaches, it should not have any value, zero. It should just look like the water. There you discharge. You are discharging very close to the intake structure there, and that means you are providing this water to them. So those are the things you will have to think when. That's why when you find the location of the intakes for water supply, you are careful always. Is there any pollution? You cannot take any polluted water and invite a problem and then start treating it. That will be healthy. So that is the reason you should have these kind of data. And what are the approximate range? As an environmental engineer or a scientist, you should know what are the approximate values. Right? People working in the field, that's why that is all important. What is the range of value? You should be able to. This is the range. You should have that understanding. Right? No, sir, it depends upon these factors. If you start telling that, so what will the other people will do? So you should give an understanding because you are dealing with the people who have different backgrounds. You may be knowing that is true. It depends, but approximately what is that? Right? That is how you do in the construction. No, people in the civil. If you are to construct this kind of a wall, how much cement bags should bring, sir? You should have understanding. Feel to whatever. No, it depends upon volume. How you will understand? Today he has to record. So that is why you should understand the approximate values, numbers. Is it? By that way, you can see. BOD, influent, effluent in the activated sludge process, measurements, ammonia, TSS, pH. Approximately, we want to have these numbers. Right? And process control data. So in the process control data, what we see the settleability, how much is the settlement of suspended solids, DO, temperature, depth of the blanket, and blanket thickness. And we see more process control data, flow rate, pH, microscopic analysis, solid concentration. There are equipments where you can find out this roughly, and you can also go and further do the analysis. Is it? There are online flow meter, online pH meters. You should be able to test it immediately. Now they are made it handy, right? And solid concentration, we talked about it. What is the return sludge, waste sludge, recycle, effluent, TSS, right? Then flow rate, inflow, return sludge, waste sludge. Waste means what? Some of the sludge will be sent to the thickeners and some will be recycled. That's why it is a activated sludge process. Then dissolved oxygen, aeration tank, effluent profile. Aeration is done in different way. You might have seen yesterday aeration, what we saw, it was aerations were fixed in the bottom. In some places it is from the top. When you do that, why you do that? One from the bottom and one from the top. Depth. If the depth is less, you want to fix it on the top because it will go on to the bottom. If the depth is too high, we want to put a diffuser at the bottom so that the, the corners are just not left like that. So oxygen is supplied uniformly. You want to find a uniform mixture of or supply of oxygen, organic compound, then will be right. Transfers also they give. If you want to have a more oxygen, small space, you want to have a more flow, then it is a design. You want to have the one from the bottom, the top, and the side. So because your area in the cities, you are lucky to have a big place here. If in the cities, very small places, but still you will have to do, right? So in that case, it depends upon what kind of aerations you have. Then the temperature do affect the metabolism rate of microorganisms. See, there are filaments in there. Anybody who are background biologists? Good, very good. And chemistry people also they study, right? In case of biology. So you will analyze what kind of microorganisms are there in the biological system. It is nothing should be unknown. There are different ways you can take a sample and you will find out, is it? What kind of bacteria are there? How they are helpful. If it is a domestic, it is different. If it is an industrial wastewater, what happens? It in the years or months of time, it will acclimatize. Certain bacteria which are more immune for that kind of pollutant, they start growing and they will be helpful. Right? That is. Then satellometer test. Use satellometer, don't use graduated cylinder. Fresh samples, take the sample near the effluent near aeration basin. Where you want to take a sample is also important. You want, if you want to take a sample where there is no pollution, less pollution, no. We want to see maximum. You cannot design the things with a minimum value or average value. You want to design for a maximum, then you want to say if it also works for a minimum value. Correct? So that is how we want to make sure when you do any inspection, first what you will do, you will see where is your sampling, how you decided, why you want to be here, why it has to be here, right? Those are the things you will have to look for. You want a representative sample data so that you can make a good design and good determination design and decision. Is it? If you want to create a model, you should have a perfect and good data to design. Then the model. If you are taken few data which are not reliable and if you do model, how it will be? You have to justify that your model criteria, how it works. So that is why those data are important. How clarifier works? Flocculating, settling, compacting, allow the biomass to settle to a reasonable thickness and get it. Right? So flocculation and clarification clarifies. We add certain things, if they are not settling, if the colloidal particles, small particles are negatively charged, they don't want to settle. So what do you want to do? Because there is the negative charges, they want to always go. So you add some chemicals, you reduce that distance, bring it together, make it bigger, so that it can settle. Right? That is a flocculation. You add chemical and put up fly mixtures and then take it to a peaceful place there. Right? Then you will do. So this is how it is done. Then clarifier problem typical causes: bulking, sludge quality, hydraulic overloading, denitrification, old sludge. You want to keep removing the sludge. You want to keep the system fresh. efficient. That is what I say. The job of those people who are responsible is not that easy, right? So that is very important what you will have to do day to day life in order to make it efficient. If your designed efficiency is 85, 90, 95, if it is performing 30%, what you will do? You will do your calculation at 95%. How it will work? That is why in the real world these data are important. That's why you do day to day, daily monitoring, weekly monitoring, monthly monitoring. All you do and analyze, apply your mind whether they are working in the right direction. That is what we do. These are some data approximately what it is reactor average 22 mg per minute settleable sludge, volume index, concentration, clarifier, return activity sludge, pH of mixed liquor, SRT, 5 days, 15 days, 15 to 35 days, depends on type of the process. So I have already explained what are these terms. It is also given in the class. So macroscopic examination, general flock analysis, protozoa counts, metazoa counts, filamental abundance and location, identification of filamentous organisms. They are responsible for degradation of your organic compound to a stable. Stable in the sense what? There is no smell, carbon dioxide and hydrogen. I said the moment the sewage comes out of the house, the reaction starts because healthy condition, temperature is there, oxygen is there, right? So that is why you will find out how much is the by the time it reaches little because they are open. There are open channels are there to take it to sewer system. If in the other countries they are closed one, right? Because of other climatic conditions and nobody wants to be open. Right? You have to be careful. Today you have seen the consequences of open channels, open sewer systems. Causes it has to flow. You might have seen many sewer systems which are designed, they are just stagnant. Why? Because you have to, when you do, you should understand there should be a flow proper, there should be a control of suspended solids. People, it is easily throw something there and they will become the tanks, series of tanks. That is why now people want to have a closed system so that you can maintain. You cannot add anything, right? So that is why if any industry or anything which is discharging, if it is discharging high sludge or high suspended solids, this will cause a problem. That is why if we go back, I was mentioning about the SSO, sewage overflow is important factor. Why it is overflowing? You should have, there is a rule, you have to inform why it is happening. Is there any problem there? How they will mitigate? That is important. If you are not getting a sewage to the treatment plant from the sewer system, it is not, it is vanishing somewhere, means where it is going, right? That also you have to make sure your system is intact. Whatever sewage is produced from the house's domestic wastewater is entering into the sewage system and entering the treatment plant. There is a sewage production, that is sure, that you know, you can calculate. But that volume has to come here, right? So that is why you can do a lot of analysis to make the system right. Right? So examinations you can be, there are many methods, scan electron, microscope, you guys might have used that. So you will find out what kind of bacteria are there, how they are, what they are, whether really treatment is taking place in the biological system, or any. We will go further for a particular pollutants. Then I will explain a little bit more about that, how we do, why you do bacterial analysis, whether is it just ending up in the sludge, or is there any treatment taking place. So that all has to be, you know, analyzed. So relative predominance of microorganism versus F by M ratio. I have mentioned a little bit about this F by M ratio. That is how the whole system works. You will do analysis, then how much VSS is, let's say, volatile suspended solids, which is a microorganism, right? You do that analysis. You will see in the oxidation part, you want to maintain the F by M ratio properly. F is mentioned for the food, right? That is the organic compound. And microorganism population, how much is there? Both in mg per liter. That is why it is ratio, right? So we want to make sure that that ratio is there. So in the beginning, what happens? Uh, okay, in the beginning, what happens? Food is high, organic. When microorganism population is low, then as the time passes, what happens? I said the energy is produced, 1/3 is used in production of the microorganism and 2/3 in converting the organic matters into stable compounds. But as the time passes, what happens? This population increases, right? And the food, the organic compound is there. When it is finished, what happens? They are go to the next stage and they are removed as a suspended solids. That is why we recycle again and rest will go to the sludge. See, they remain for a fraction of a second and they do such an important job for our human beings. All the pollutants which are produced by us is just finished by my part. Such a great mechanism, right? So we want to use them. But you can use it properly. But you should have other things also work along with that, right? That is why you have to create a good environment for bacterial growth. If you leave some toxic material, which they will all die, your biological process is gone. Gone in the sense it will take time again to re-establish. If you leave a high temperature, someone, one industry is there, whole town will just suffer. So I want to realize people who are working how important your job is. On other side also, right? They should synthesize. See, if you do, what happens? You have on a big high MLD, or MGD treatment plant, and if one or two people are just living and they're discharged without treating, without caring, so whole things will be, that is, whole thing will be in problem. That is why it is important to each component has to be verified and to make it more successful. So that is the very intent. That is why these regulations, you have seen the first 3-4 layers, how they are built. Yeah, there is nothing is left out. If it is left, what you will do? You will create how to solve it. So that is why you have a system uh, consolidated, compacted, concealed system so that the system work towards success. So standard software produces useful analysis and representation of data, right? You will analyze, you will find out what is going on. What is going on is not hidden, it is there. So, observation of the appearance and characteristics of the reactor content should be recorded with analytical data in your database. You can visually see whether it is healthy. People see that whether it is healthy or not. Healthy microorganisms sludge is, you can see little grayish color. You can easily identify. People who work 10 years, 5 years, do analysis, data, they will be having some observation. Always. You can say, this is not okay. That is why the major responsibility of cities to protect the infrastructure. That is why you always keep an eye influence from where it is coming. What is the concentration? Is it causing any issues? Right? So that is the responsibility of observation and data important to the process control. Common operator error. Keep MLS too high, SRT is too high, keeping DO too high. High and low is not good because you at the same time you have to be economic, right? You cannot use the energy enormously and make it uneconomical. Even though if you need this much energy, 50% is okay, then if you are spending 100%, how it is economic? So that is economic people will catch you how you are running, right? So how you can do that? You have to analyze every corner of that and see how much is required, because the treatment plant is designed from minimum to 30 years. What is the maximum? See how much is required. There is a flexible. That is what you will have. So keep a DO too high, keeping recycling flow rate high, not paying close attention to the variations in the influent BOD and TSS loading. How much is the loading? Slug loading, we talked about a little bit on the slug loading. Suddenly, if you leave lot of high hydraulic loading as well as the organic loading, it will disturb. That's why you see, not analyzing operating and data correct. That is what the number is important. You have to analyze the data correct, right? Then keeping too many reactors in service. That is why you do like that. Why you design a multiple tanks? Because you don't know. You might have seen the variation even in the sewage inflow. If you need minimum, then you will operate one tank. If you need another, in a after 5-10 years, there should be a design for the second tank, third tank, all in all. If you need one and if you keep operating all the three, what is a waste of energy? So that is also important in doing that. And sludge, filamentous bulking, possible poor effluent quality, potentially high sludge blanket thickness that may lead to solids washout during and after major storm event. That is why sewage treatment plants are protected. If there is a big storm and if it is just flood everywhere and sewage will mix in the storm water, enter the people, enter the streets, in the town, will cause a disease. Right? That is why we have to be careful. I said most of the 80% of your diseases are with the water. So you have to be careful. So problems with the high DO, over oxidation of the biomass, wasting energy, causing high electric bills of the plant, creating too much turbulence in the reactor. Right? It's not necessary. Then automated DO control. We have automated DO control also. How much is required? That there are automation. Somebody was asking AI and modernization equipment. That is what we do. When we become more smarter, we use a more. Then energy saving is the big one in this you have seen. And if the plant cannot afford automated DO control, install timers, aerators. That is also that is a solution. Problems with the high flow rates, sludge bank thickness in the final clarifier is too less. Sludge is final clarifier does not have enough time to compact. Return activated sludge is important. How much you return, right? Low TSS concentration may make a sludge processing operation more difficult. Additional power cost always. When you are pumping, you should always remember, because why it is important. Wastewater is produced 24 hours, 365 days. So little change, little saving makes a big difference. Problems with overlooking of influent variation, inefficient use of aeration equipment, daytime organic loading, and nighttime organic loading. That is why I said that organic loading also will change. Daytime, if in the nighttime everybody will sleep, no sewage is produced. Daytime, in the morning, everybody want to use it. Certain variation. That is what we do is we put the equalization tank, right, and make it uniform. Nighttime nobody use water. Morning everybody would during about 6 to 8, 10, 11. Everybody. Afternoon there is no. So hourly variation, seasonal variations, day by day variations. If a big festival is there for a week, people use a lot of water. So all that has to be considered. So that will reduce lot of your energy required for the reactors. Wash out of biomass, reactor biomass to the clarifier during a period of high infiltration and wash out of biomass to the effluent due to a high flow rates. Final clarifier, right? So what happens if there is a slug load with maybe low organic load, lot of hydraulic load, you will not be able to give a proper detention time. What happens? Your sludge will go along with the effluent. See how precise it is. We have in the system, usually online system, where you can see how that is going. You can physically with numbers changing. So that is what the automation, and now they are adding a little bit AI on that. So always help is there. Right? Oxygen demand for the aeration drops in the middle of the night and peaks in the morning. That's why when there is a flow changes, your oxygen requirement also changes, because oxygen requirement and organic loading go side by side, even the hydraulic loading. So that is why it is important to have a balance. Know your plant operation. Know all this determination, MLSS, concentration that optimize the process performance. Know your basic practices, keep your plant flow pattern. Right? How you do? You will analyze the data and see what is the flow, why it is going up, why it is coming down, what we should do. You will learn and become more smarter and smarter every day. Right? So this is how you will have to do, interpret the results, analyze. Right? Reduce aeration, reduce nutrient discharge. That is important. In an oxidation disk that is operating in the aerobic mode 24 hours a day, expected effluent nitrate, nitrogen is to be this. You should know the approximate value of these nitrates, oxygen concentration, loading, hydraulic loading, organic loading, right? Before and after effluent quality, what should be the impact on the mixed litter at one facility? One example, how it was. And this data changes from treatment plant to other treatment. It may not be, you cannot apply what are the results for this to other, because parameters are different. Authorization is different. If you are able to authorize to do this much, the industry will do that much only. Whether it is right or that, somebody was asked, professor was asking question. Oh, yeah, that's he said. See, Your question was right. But who has given the authorization? How we will interpret it? That is what I was telling. No, they have given. But if you say what is the result, why he will answer that? He will not answer. I am doing this one. I am not responsible for that because authorization is. See, you see the important responsibilities, right? That is why if you are there tomorrow, today, or people, you will start working there, right? If you are working, you are responsible. Easily they will say you have written. You can say, oh, if you are learning, yeah, we have written. We will change that. We will take the legal advice. Whenever we write, you will learn. You will become more smart, right? So that is all. Other benefits, turning aerators off, oxidation. If it is not required, no need to run that. If there are 3 or 4 oxidation ponds which is or in series, you see how much is the wastewater coming in, that only you will. Others you will keep it extra, you will use it, clean it, make it 100% efficient. That is why you please always do 1 or +2 extra, not the minimum. Okay? That is why we do for minimum, maximum. Accordingly, we will go on. Alkalinity will be generated, possibly eliminating the need of for additional lime soda. Alkalinity will be generated. Then you have to bring the pH down. You have to make it appropriate, and then okay. So, I have to put questions. No questions. I will say this later. So, any questions?
Any questions?
So, what we learned in this? So, to summarize, what happens? What we learn in this? That is important. What you learn. Yesterday you saw how the biological system works. Now you have an understanding. Biological system works, bacterial load, it goes from here to here, then it is removed, organic compound is removed, converted into stable compounds, nitrate is removed, POD is reduced, TSS is reduced. At this stage, this is a biological process. Then we give, if you are discharging, we give a little disinfection or ultraviolet and then make it safe discharge. If you are applying it to river, then you make sure that it will not cause. The river means flowing river. I should always say flowing river, right? River is always flowing, right? So if you are applying it to the land, what should be your discharge? The discharge standards changes. Is it not the same? If you are applying it to the land, little suspended solid is okay. How much is okay, you have to see. You should have a monitor. What their standards are different. Why those standards are different? They say that it is possible to accommodate. You don't want to spend more. Yet at the same time, you also want to give a industry people. If you need a TDS or the suspended solids at this level is fine, it is okay. Hey, no, you have to do it. If you are doing it 20, you want to make it 5. It is not like that. You also see how much I told you earlier. We have in a system, land, all water, river, it has some capacity to treat itself. So that is why you want to do that privilege, right? So that is why you should make sure that how the standard works, what is needed, where it is, that decision determination you will have to make, right? Where it is going, how it is going. So that is what we study, whole process, how this works. Today what we did is we see what is the numbers, how best you can operate. We are going little further. When you know the process, then you have the values. This is the process. Okay, what it means. If I say 20 to 10 means what? 50 to 100 means what? You should be eminent. And where you are applying, I gave you an example. Where you are applying, which group you are addressing, right? Different group give their expertise on that, right? So those are important data. And what you studied in this, I have told you earlier also, you have to write half page what you have understood. That is important for you. Not only this, everywhere. If you do, just write half an hour, half page. Understand what you did, what you have done, what you learned. Simple. You may read or later you can see, just keep it for yourself. It is maybe useful. That is always good, right? Writing and keeping it. So that is what you learned today. What you did, different group, different background, how you use the expertise and see what you need, what error you make. It is not 100%. You understood now how much judgment is required. Why you learn all this? Why you learn all the theoretical background? You do masters, you do study, different studies. What do you do? To apply, right? If you are not applying, what happens? This number has a meaning. That is what I said. If I say the number means wastewater has a language. That language you should understand because you are a competent person, right? If you are a competent person, if you are an expert, you know that number, right? That is what different background you take an expert. If you don't know, nothing wrong in saying I don't. It is not necessary to say I know. This is not known. You are more expert. You put your. You get a second look, even though you are expert. Always you give it to somebody else. See what angle is. That is how you can make it more concealed document also. You do like that. When you write something, can you read this one? Oh, this I, because what you write, a common person should be able to understand. You should be able to understand yourself also. Today you are writing and after 10, see, I don't understand what I have written. I wrote poorly. I could have written this way. So that is how you will become more smarter and smarter. If you put your focus on it. And other time you enjoy. But when you are doing something, be at it. That is very important. Right? All the time you no need to think this one. But when you are doing this, think thoroughly. You are 100%. When you go, this is how you have to, that is the way I think. That's what. Okay. Any questions? I understand. No question.
Good morning, sir. So, in fishing industries, when the octopus and squid they are exported, so they contain ink sac, so which is removed from the octopus and squid and all. So they get dissolved in the water, or the shellfish contain the biotoxins, which are also removed by washing in water, and it get mixed in the wastewater. So how are they separated, or how are they removed from the wastewater? Because if they will go in the river, they can cause poisoning and all. So
But first, your job is not to allow them to enter. Right?
yes, sir. So how in treatment plant, how they can be removed?
They can remove. That is what you build a series of treatment plant. You make sure that nothing enters the river.
So they can be a part of they can be like removed like a biosolid, that they get mixed in the biosolid because they are dissolved in the water.
Which
So they are
dissolved
liquid.
also you do the treatment. It is not necessary that only what you can see, what you don't see. There are many pollutants you don't see at all. You need it. That is why you analyze. You find out this is the contaminant present. Then you find out. Otherwise, it looks like a what? Is it? So that is why if it is dissolved means what I see only that is a pollutant. No, many pollutants you don't see. That is how you do. Where you see these bacteria do a very important job. You don't see. Then but somebody is doing. Who is doing? That is why you analyze, you use equipment, you find out data. So your job is not to enter which is not taken care by the environment. Right? So that is possible. If you do that, it becomes enter the fish, and then if you are exporting, no one will take
Yes, sir.
exporting. But here, if you have market, if people don't know, they will do.
Yeah,
So that's why when you send any material outside, they analyze whether it is right or
yes.
why they will think, right. So that is those things are important.
Thank you, sir.
There is no shortcut or alternative, right?
Thank you, sir.
Thank you.
So we will meet after 5 minutes. Thank you. Thank you, sir, for this lecture.
Okay.